So welcome to this first lesson in Algebra 1 where we're going to go over some things you've learned before, and I'm going to try and help you correct any errors you had in the past and help you to go forward so you can be more successful in algebra. And so for this first lesson and maybe the next lesson or two, we want to talk about calculators and the order of operations. Now, there are several reasons why I want to talk about calculators. Some have to do with IEPs, others have to do with, I know you're probably using a calculator at home, whether you're supposed to or not. And the other one is, I just want to show you how to use them properly. The second thing is we're going to use order of operations as a mathematical application that you have to know to be able to use a calculator properly. So, goal one is, for this lesson, is I want to show you how to use tools correctly. And for our class, the tool is graphics or a regular calculator, scientific calculator. And our second goal is going to be practicing order of operations as an application of mathematics and calculators. So I want to give you just one quick example about using tools correctly. And so when you use tools correctly, one of the key things you have to know is that if a tool is used improperly or in the wrong context, then problems are going to happen. So for instance, what if I told you to dig a swimming pool in the back of your yard? Well, what's the proper tool? Do you want to use a shovel or do you want to use an excavator? Well, if you choose a shovel because you know how to use it and it's a great tool, but to dig out a swimming pool, it's going to take forever. It's the wrong context. But if you choose an excavator, that's the right tool for the job. Okay, here's another example. What if you're a person who works on body work of cars and I give you two tools? You want to use a sledgehammer or do you want to use a ball-peen hammer? Well, what's the right hammer to pound out some dents? Well, the ball-peen hammer is going to be the correct tool in this case because it'll gently help pop out those dents. If you use a sledgehammer, all you're going to do is make more dents, and so it's the wrong tool. It's the wrong context. What if you're a doctor or a chef? You're going to use a chopping knife or a scalpel. Well, a chopping knife is the right tool for a chef because they can chop vegetables properly. If they tried to chop them with a scalpel, they'd just make a big mess. But a doctor, if they use a chopping knife to take out your appendix, they might end up taking lots of other things out. So again, a scalpel is the right tool for a doctor, a chopping knife is the right tool for a chef. And both of them do similar things. They cut. But one cuts very gently and one cuts in sort of a harsh manner. So the right tool for the right job. So what I want you to do is think about what are tools that mathematicians use. Okay? And in the chat box, I want you to write those down. So I'm pausing the video so you can do that. So really, one of the things I want to show you today is that some calculators are better than others for certain jobs. And our context is going to be our old friend order of operations. And what I'm going to do is I'm going to do a little web tour for you and take us to another web page and show you some different calculators. So now we're back from looking at all those different calculators, and we kind of have a better idea of which ones are better for the kinds of jobs that we're doing in 7th, 8th grade, 9th grade math. And so we know which ones are better. But what we'd like to do is we'd like to see how can we use that to help us do order of operations. So the first thing I'd like is I'll give the microphone. Somebody please tell me what PEMDAS stands for. Yes, that's correct. PEMDAS stands for parentheses, exponents, multiply, divide, add, subtract. And one of the things I'd just like to emphasize for a moment here that nobody may have told you is that multiplication and division are equal operations, and addition and subtraction are also equal operations. So in other words, you do these when you see them from left to right. To right. And what that means is that in an order of operations problem, if a division is more on the left than a multiplication, you're going to end up doing that division before you multiply. For example, suppose I had 10 divided by 5 times 6. I would not do the 5 times 6 first because it's multiply. I actually do multiplications and divisions from left to right. So I do 10 divided by 5 is 2 times 6. Additions and subtractions work the same way. You do those from left to right. And so now that brings us to the big purpose of this lesson. What we'd like to do is we'd like to do an example, and I'm writing this example on the blackboard currently as I speak, and we'd like to do order of operations, but I'm going to show you something that maybe you've never learned before. When I do an order of operations problem, I don't just start off by doing it. What I do is I look at it. And I look and I decide what is it that I'm seeing. How do I decide what to do first? And so what I do is I underline the operations and I underline any parentheses or exponents I might see as well. So what I notice is I see an add, I see a multiply, I see a subtract, but I also see some parentheses. And so because I see that, now I can look at PEMDAS. What's the order of operations? Well, the order of operations is I do parentheses first. So whatever operation is inside the parentheses, that's what I'm going to do first. And so let's write the problem clean now. I've thought about the problem, and now I can go ahead and do that. So I do what's in the parentheses first. So my first step, the 10 plus the 3 multiplied, I don't do that at all. I do the 4 minus 6. And 4 minus 6 is -2. That's correct. Now, what if you have a problem with doing 4 minus 6? This is a perfect time to use a tool, a calculator, to help you make sure you get it correct. And the proper way to use the tool is you say 4 minus 6 and you write your answer here. You may have wrote 10. You may have wrote -2 or +2. And so you write your number down there, then you go to your tool and you check it. And you say 4 minus 6 on your calculator, that's equal to, oh, negative 2. Therefore, you can come back and you can change this to a negative 2 if you got it incorrect. This is proper use of the tool, not doing the whole problem and you just writing an answer. It's you doing the problem and checking your work along the way. I'll show you how these look on the calculator in just a moment. So that takes me back to, let's go ahead and finish the problem. So what's the next operation? Well, now I have an addition and a multiplication, and according to PEMDAS, I would do the multiplication next. So this becomes 10 plus 3 times a negative 2, that's a negative 6. In this case, I just use parentheses as a separator. Here I use them as multiplication. Here they were a grouping symbol, and when they're a grouping symbol, that's when you do them first. So 10 plus a negative 6. Now, again, you can use the tool to make sure you multiplied that correctly. Oh, 3 times negative 2 is negative 6. Maybe you wrote a positive 6. Maybe you wrote 32. You just copied it wrong. So it's always important that if you struggle, especially with positive, negative number arithmetic, make a guess, check your work. Guess, check your work. Guess, check your work. And now we get to the final step. We only have an addition to do, and 10 plus negative 6 is 4. Again, I could use the tool and do 10 plus negative 6 to make sure that I did it correctly. Now, based on this, using my tool to check work I'm not sure about, I can see that I've done the problem and it looks like I followed the order of operations. Is it correct? Well, now here's why we talked about all those calculators. What you want to do at this point is you want to do a check of the whole problem. Did you not make a mistake along the way? You may not have used the calculator to check your in-between steps. So you want to check the whole problem to see if you made a mistake. And it turns out the calculators I showed you, the ones that have an extra line so that you can enter math the way it looks, are the best calculators to use. And so I can now go back and I can type 10 plus 3 times 4 minus 6 and punch that in, and my calculator will follow the order of operations, and you will see that I get the answer 4. And what I want to do is I want to show you a picture of what this looks like on the calculator. So up in the above corner, here's our correct work from what we did before. Notice how when you do an order of operations problem correctly, it always makes kind of a triangle in visual shape as it shrinks down to the answer. And when I go to a 2-line or a multiple line calculator, you can see that what I have entered is 10 plus 3 times 4 minus 6 in parentheses, exactly the original problem the way it appears, and then I press enter and it gives me the answer. And so this is what I call checking my answer. Alright? I don't want to look in the back of the book. I don't want to go anywhere else. I just want to make sure that I did all the work correctly. And so step by step, and we showed you how to use the calculator along the way if you need it, that'll get you an answer. And then in the end, you can check all your work. And with a little practice, you won't even need to use the calculator step by step. All you'll ever be doing is doing the steps and then checking your work to make sure it's correct. This is proper use of the tool. If you go to your homework and use the calculator just to get the answer, you have not learned how to do the problem. And so in mathematics, we must learn how to do problems and not use checking techniques to do it for us. The only time we ever do have technology do problems for us in mathematics is when we already know perfectly how to do the problems on our own. And so engineers and mathematicians use technology to do problems for them, but very often they'll check by doing it the long way. So it turns out the world's a very interesting place, but your goal is to always check your work, not do your work on a calculator. Okay, that's the end of this lesson.